And we are live and on the air. And this is Ed Dyer, and this is the TWIS Minion Science Island Hangout. And joining me today are AJ. How you doing, AJ? Amy.
Hello.
Amy, who has been knitting away there. I don't see any birds circling over your head, though. So
they're in bed.
They're in bed. Okay. Bedtime for the birds.
Yeah, they go to sleep pretty early.
Oh, they're early risers. You're on a different time schedule from them, I presume.
Yeah.
You got a wake-up call in the morning?
Yeah, from the birds.
That's different. Instead of a rooster crowing, you have actual birds, probably flying around, landing on your bed or something.
No, they just start making noise.
And also joining us, although he's on the road, hopefully with his 2 eyes on the road, instead of the hangout here, Dale. How you doing, Dale?
I am doing super duper 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 well, and yes, both eyes are on the road, and my phone is tucked away in the cup holder, so it's all good.
There you go. Amazing. A telephone, a device where you can go live and join us in a hangout. And not to date myself, well, to date myself, but the first video phone I can remember was in a comic strip called Dick Tracy. And Dick Tracy was the 30s or 40s into the 50s. And he had his little video mic on his video phone on his wrist, like a clock. And also joining us is Jani in Finland. How you doing, Jani? Finland. All right, we do have some interesting stories, and I think we're going to have some interesting discussions. The real fascinating one, the crazy people at Philae Lab are they're going to run an experiment to see whether or not we live in a two-dimensional universe. Are we living in a hologram? Then I got another story, and I think we'll have fun with Dale talking about, will the next war with Canada be fought over water? We are doing such a great job of managing our water, I'm sure there's going to be no problem. Haha. Another real interesting infographic that Dale shared on Facebook, and that is differences between the amount of money people are donating to diseases and the actual death rate of different diseases, and the wide discrepancy between those two things. We have an article, and this is one of Amy's articles in Spaceflight Insider, talking about Rosetta. And Rosetta's lander, is it Philae?
Mm-hmm.
Philae. Going to be landing on a comet in November. Got a story. I've added Brazil is thinking about growing some genetically modified eucalyptus trees, and they would be much more productive. But the question is, you put these genetically modified trees into the Amazon rainforest, I don't know. You could have problems with how they're going to affect the other trees in the rainforest. Another very interesting article about photons, taking pictures using entangled particles. So, let us start. And this is from Fermi Lab's National Accelerator Lab. And they're going to be conducting an experiment called the heliometer. And they're collecting data that will answer a question, including whether or not we live in a hologram universe. Reading from the article, much like characters on a television show would not know that their seemingly 3D world exists only on a 2D screen, we could be clueless that our 3D space is just an illusion. The information about everything in our universe could actually be encoded in tiny packets in two-dimensional space. And I think this is something really that goes in line with Dale. Everything is a computer program. It's all a program. And this is kind of in line with that. Get close enough to your screen and you'll see pixels, small points of data that make a seamless image if you stand back. Some scientists think that the universe's information may be contained in the same way, and that the natural pixel size of space is roughly, are you ready for it, 10 trillion times smaller than an atom. And that's pretty small. And that's a distance called the Planck scale. We want to find out whether space-time is a quantum system, and that's a biggie, because the problem has always been making quantum mechanics compatible with space-time and gravity. Quantum mechanics suggests it is possible to know the exact location and, let me reread that. Quantum theory suggests it is impossible to know both the exact location and the exact speed of atomic particles. If space comes in 2D bits with limited information about the precise location of objects, then the space itself would fall under the same theory of uncertainty, the same way that matters continues to jiggle, they say, quantum waves. Even when cooled to absolute zero, this digitized space should have built-in vibrations even at the lowest energy state. And the idea is with quantum mechanics, everything is made up of a quanta of something. And now if quantum mechanics were to apply to space-time, it would mean that you could drill down space-time itself and would consist of these tiny pixelized packets of information. And that's what space-time would consist of. Essentially, the experiment probes the limits of the universe's ability to store information. If there is a set number of bits that tell you where something is, it eventually becomes impossible to find more specific information about location, even in principle. The instruments testing these limits is Fermilab's heliometer or holographic interferometer, the most sensitive device ever created to measure quantum jitter. Operating at full speed, the heliometer uses a pair of interferometers placed close to one another. Each sends a 1 kilowatt laser beam at a beam splitter and down 2 perpendicular 40-meter arms. The light is then reflected back to the beam splitter where the two atoms recombine, creating fluctuations in brightness if there is motion. Researchers analyzing these fluctuations in the returning light to see if the beam splitter is moving in a certain way, being carried along by a jitter of space itself. Heliographic noise is expected to be present at all frequencies, but the scientist's challenge is not to be fooled by other sources of vibration. The heliometer is testing a frequency so high, millions of cycles per second, that motions of normal matter are not likely to cause a problem. Rather, dominant background noise is more often due to radio waves emitted by nearby electronics. The heliometer experiment is to design and identify noise from such conventional sources. If we find noise we can't get rid of, we might be detecting something fundamental about nature. That noise is intrinsic to space-time. So that would be pretty interesting. That would be, first of all, mind-breaking. Mind-breaking? That would be
mind-blowing.
major breakthrough, is what I was trying to say in English. is a major breakthrough, because then it would marry quantum mechanics with space-time theory, Einstein's theories. A question I have for you guys is, Fermilab finds out that yes, we are living in two-dimensional universe. You are living in a hologram. You are just a hologramic image. Now we know we are packets of information because that's all atoms are. AJ, what do you think? You find out you're a holographic image and a holographic image in a holographic universe. How'd you feel?
Well, I'd want to know who has the hologram machine.
Who programmed you?
Who's my maker?
So you think there'd be someone controlling?
Where's the wizard?
The wizard. Oh, okay, there we go. The Wizard of Oz. Could be God. Okay. Or it simply could be the intrinsic state of the universe and nature. Quantum mechanics at its most basic. Yeah. Would it bother you, AJ? Would it change anything about how you think, or any significant change?
Yeah, I've thought about it before. I've seen these kind of articles popped up recently, and I've thought about it quite a lot. But yeah, it would change how I was viewing the world, I think. If it is a world, it's a hologram.
Matrix.
The Matrix. There you go. Okay, Amy. What do you think? You're just a hologram. You're just a holographic image in a holographic world. Can it bother you?
I probably wouldn't know any better. Ignorance is bliss. No. No, I don't know. Be interesting to read some more about this. Didn't get to read the article.
Yeah. Okay, Dale. Now you're the computer guy. You think everything comes down to computer algorithm anyway. So would this make any difference in how you think about the world, let's say? Would it bother you at all?
Can you hear me?
Yes.
Oh, good. Okay, because I switched mics and I wasn't quite sure if it was working. That's all.
Can't quite hear you.
Am I okay? My level's okay?
Maybe up a little bit. You're kind of low. Kind of soft.
Yeah, I can't hear you.
Okay, hold on. New microphone.
You got to increase the sound in your hologram there, Dale.
How about that?
There you go.
Is that louder?
Hey, now you're good. Now you're good.
Okay, awesome. Yeah, I'm completely comfortable with that. I think it's going to end up that basically life comes down and nature comes down to particles and to very finite pieces of information. And at least that's what I hope it is, because I think the Matrix is really cool.
Mm-hmm.
Now, I guess that means a certain level of control too, right? Because if that's what nature really is, and that's what we're living in, then analog doesn't exist, and we're all definitive pieces of information, which is awesome. What do you think, Ed? Are we or not?
Well, I think we are packets of information. We are made up of packets of information. That's exactly what atoms are. That's what the fundamental particles are. They are packets of information, and different packets of information interact in a certain way with each other. Mm-hmm. So at that level, I think yes. I don't know if I could call that a hologram universe. I don't know if I would make. It sort of sounds like it. So I would be completely comfortable with this, and I think they're going to find out. I would expect that they will find out that that space-time does fit into quantum mechanics, and that there is, when we look at space-time, I don't know if you want to call it vibrations. There's some sort of
Strings?
Yeah. Some sort of very intrinsic, they called it intrinsic. Some piece of information in space-time that can't be broken down. The more interesting thing is, I think, for most people, is this idea of uncertainty, because that's a major part of quantum mechanics as well. The uncertainty principle, which they are, at Fermilab, if this experiment proves out, are saying then space-time, that theory of uncertainty also applies to space-time. And that's why Einstein had such a problem accepting quantum mechanics, the uncertainty idea behind it. And I think that might bother some people, uncertainty, living in a world of uncertainty.
Yeah, I definitely think that would bother some people.
It would certainly help if we can marry space-time. And space-time is a hard thing to even grasp, these ideas about space-time, what it is. But if it does come, if it is quantum mechanics, as well as I can understand quantum mechanics, then I could get my head around space-time, I think, a lot better.
I think there's a large club of people that don't understand quantum mechanics, and if Feynman is correct, he said, if you think you understand quantum mechanics, you don't understand quantum mechanics.
Oh, yeah.
So, it's pretty confusing stuff.
I think the idea behind it, though, everything can be reduced to a quanta of something. That's the main idea that I can get my head around. Whereas with space-time, space, time, that's a little bit harder for me to get my head around.
It's a tough one. But if you imagine, I think someone explained it with like a railway car that could travel, say it's traveling 100 kilometers an hour, and you agree that light has a finite speed, right? You imagine this flatbed on the railway car, you're standing there with a flashlight, and you point that flashlight out in front of the railway as you're going along the tracks at 100 miles per hour. The speed of light is finite, so do you add that to the speed of light? Well, you can't, right? Because the speed of light is finite. So something has to give, and what gives is time, right? So space and time have that interrelated properties, and I think that's a really nice way to explain it, where if you're on that train already and you're pointing your flashlight in front of you, you can't add the speeds together. So something has to give, and what gives is time.
Well, going forward, well, I saw a special on PBS that dealt with space-time. And I don't remember all the details of anything, but basically, okay, so you've got two people, and one person is on point A and the other is on point B, and they're a million miles apart. Okay, theoretically, if they move, if one person moves, then they're moving in space-time, and which direction they're moving in, either left or right or closer or further apart, they could be theoretically moving backwards in time.
Yeah, I think that was a Brian Greene special. I think I saw the same one.
Yeah.
And I mean, they explain it very, very well. That I think they were talking about the when you cross those vast distances. And again, I don't remember exactly what they were talking about, but I remember at the time when I saw it, it was like, yes, that makes complete sense. And the logic that they use, you can't escape it. They're using known physical principles, and as they walk you through this imaginary space between these two entities, that yeah, it's you're playing with time there, and yeah, space and time are interrelated for sure.
I mean, I can see the words. I can see the diagram. I can shake my head up and down and say, yeah, you know, that makes sense on the diagram. But still, fundamentally, thinking of time as being malleable. I know that they've already done the experiment where they had an atomic clock, and they had an atomic clock on the ground, and they put an atomic clock on an aircraft, and the time moved. Time was different between those two clocks. Time moved infinitesimally differently. I forget, you know, fractions, millions of a second, 60,000ths of a second. But there was an actual difference in how time moved between the time on the clock on the ground and the time on the clock in the aircraft. So I know it's proven. I know it's a fact. But again, it comes down to thinking of time as something that, you know, going backwards and forwards in time. It's hard to get my head around that.
I think
However,
you're right, it is. It's great. It's awesome.
but I like this article, and I really hope that they are able to show they are able to better marry space-time and quantum mechanics. Now we're going to move into another fun article. A fun art. Well, actually, you can't see the article, can you, Dale? Because you don't have it in your chat area. So
I do now. Oh, I don't.
Let me pop. And this is going to be story number 2. Talking about, okay, Dale, are we in Canada going to go to war over water? And this is an article written in Tree Hugger by, I believe, a Canadian by the name of Lloyd Alter, A-L-T-E-R. And he said, and I believe he's a Canadian here, and this is how you can tell, reading Alan Taylor's Civil War of 1812, it becomes clear that it was really about real estate and resources. I wrote in a review of the book that the real point of the war wasn't to annex Canada and to push out the British. The War of 1812 was less about the war against British than it was against the Indians. British supported Indian rights in the Ohio Valley, and this was blocking American westward expansion. And he quoted, this is an American, obviously, to condemn vast regions of territory to perpetual harshness, barrenness, and solitude that a few hundred savages might find wild beasts to hunt upon was a species of game law that a nation descended from the Brits would never endure. There you go. Wilderness. Barren wilderness. The Great White North. Much of the same situation exists today, he claims. California is going through the worst drought in recorded history, sucking its aquifers dry, and that is true. Lake Mead, behind Hoover Dam, is at 39% capacity. It supplies 90% of the water to Las Vegas, and if it drops another 30 feet, the water outlets will be above the surface. Professor at Scripps Institute, Tim Barnett, says the situation is as bad as you can imagine. It's going to be screwed, and this means Las Vegas. And he says relatively quickly. Unless you can find a way to get more water somewhere, Las Vegas is out of business. And you know what? I think he's right. I don't think it'll happen maybe in the next decade or two, because we have this, you know, this fairly large town, Las Vegas, that's created in a desert. It only exists because of, you know, the water we dammed up and what's the word? We've moved the water from one area to provide Las Vegas with all its water. Doing the same thing in California. Meanwhile, north of the American border is a vast region of territory, most of which is perpetual barrenness and solitude. He said 90% of Canadians' population is huddled for warmth. You guys are huddled for warmth within 100 miles of the U.S. border. Is that true? Are you guys huddling there?
Well,
warmth near America?
I guess the thing is, like today it was I don't know. We do Celsius, right? We were 28 degrees Celsius. I don't know what that is.
Oh,
Probably.
well, here it's been like 36, and that's like 98 degrees, so.
Okay, so we're like 85
Yeah.
Fahrenheit. It's beautiful here right now. And our winters are when I was a kid, our winters were brutal. But, you know, global warming, at least I think I can attribute it to that. It's, we just don't have the same winters we used to have. It's actually quite okay. We have the odd winter now that can be a little cold. But yeah, things are, you can really feel it up in the northern latitudes that the planet is warming for sure. You can feel it up here. Like when I was a kid, it was dangerous to go outside, and they would have moments where, okay, nobody's going to school today, you know, for the next week. Those sorts of things. That doesn't really exist. We get the odd little cold spell, and that's it. So for cold, yeah, it's really not bad. The summers are beautiful up here. Fall and spring are nice, so it's warmer for sure. So that's fine. And for water, it's silly to think that U.S. and Canada. It's almost like having somebody, you know, in the same family. We squabble once in a while and stuff like families do, but blood runs thicker than water. So you know what? We're going to build pipelines or whatever we need to do, and we'll gladly sell you the water. Yeah. And everything will be fine. And I think about, you know, the Texas oil and the commodities we had to ship up north here. There will be trade. The U.S. will, you know, you're such innovators down there with technology. We'll be buying a lot of the technology from you guys, and there will be lots of trade to come. So I think the story is kind of bogus. You know, we're not making, you know, what
Sensationalism.
It's what?
Sensationalism.
It's sensationalism. It sure is. No, nobody here wants to. We're making our back
We're
bacon
going to keep the
cannon.
water from you, so you guys better start to panic, because Canada's not going to share.
You better start sending the destroyers and everything up here. You know what you'll get is a bunch of guys in toques. Hey, come on over here and have a beer, eh? That's what you're gonna get. How can you shoot us? How can you shoot us? You can't shoot us. We're welcoming.
Here, have a Molson.
Yeah, that's
It's
I think
silly.
in this article, I'll just go on a little bit further because there have been some pretty wild schemes. There have been a number of proposals to divert Canadian water south to solve Americans' water woes. In the 1950s, the U.S. Corps of Engineers proposed the North American Water and Power Alliance, diverting western rivers to a giant 500-mile-long reservoir that would hold 75 million acre-feet of water, enough to feed the West and even Mexico. Now, I don't. Did you know? Were you around when Lester Pearson was Prime Minister of Canada? He's referred to as beloved Prime Minister.
Lester B. Pearson. No, I wasn't around.
Well, I don't know if your prime ministers are beloved anymore or not, but this is this great plan of the American Corps of Engineers. The reservoir, 500-mile-long reservoir. A snap, right? Piece of cake. And actually, the biggest opposition to it was the environmentalists, strangely enough. Would do maybe minor damage, you think, perhaps to the environment. The environmentalists refer to it as brutal magnificence, unprecedented destructiveness. So I don't know, 500-mile-long reservoir. Exactly what they would do in China and have done in China. And another project, and this was something suggested by an engineer, Thomas Kiernan, and that was the Great Recycling and Northern Development Canal. Grand concept. A huge amount of water flows from Quebec and Ontario into James Bay at the bottom of Hudson Bay. No problem if you need water. You just build a giant dike across the top of James Bay and capture all that fresh water. 2.5 times the volume of Niagara Falls being pumped overland to Georgian Bay and Lake Erie. Before construction is complete, the total value, social, ecological, and economic benefits in Canada and the U.S. will surpass all of the project's cost. And another one of your prime ministers, a guy named Mulrooney, loved the idea. But Canadian conspiracy theorists, thank you, Amy. They said that this was just all a scheme, and that it would agitate the Quebec separatists, which would touch off the Canadian Civil War and plunge the Canadian economy into depression. And then impoverished Canadians would look to the canal project in North America to bail them out.
Wow. A bunch of malarkey. Yeah, no, Canada is not going to withhold their water. We're going to play ball, mostly because, too, I mean, things naturally evolve over time. And what will happen is, you know, if they have to pipe it in or whatever technology they have to use to get water in, if it indeed has to come from here, and I'm not even close to being convinced that we'd have to go to, you know, you're surrounded by oceans, and we're going to figure out effective ways to get water from the ocean. If there isn't already, I bet you there's already some good technologies that are coming about. But if it had to come down to that, I think what happens over a longer period of time is, you know, in Vegas, it'll get expensive for water, and they'll have to charge for it. As a result, less people will live there, and people will slowly migrate away from there. And you know, things always seem to slowly, the ecology of these nations slowly balance each other off, and I think it'll be fine. And it'll take some time, but yeah, I don't. Hopefully, it won't be a sudden jolt. I don't know what will happen in that situation, but you know, if it does, if it's something sudden, then people will have to, I think, move from those areas, because I don't see a very quick solution. I see long-term solutions.
And there's two kinds of solutions. The one I prefer, which is managing your water better, using different types of agricultural practices such as drip irrigation, even in the cities, you can certainly conserve water. Find ways of conserving water. We certainly can find ways of making more efficient use of our water. We know how to do it. We do know how to do it. But a difference is, and this is where the problem can come in, I think, is that, one, you can conserve and be efficient in how you use things. That isn't necessarily typically how the American public or the American government tends to solve some of its problems. They use technology. Our friends, the Army Corps of Engineers, for instance, doing things like, you know, like Las Vegas. Okay, well, why would you want to have a big city like Las Vegas in the middle of the desert, primarily built on gambling? You have the San Fernando Valley in Los Angeles, which only exists because 40s, 50s, the California, I forget the guy's name, it was the California Water Project something or other, and he basically paid off a bunch of people and got a lot of water diverted from the Colorado River down into Los Angeles, which is basically a desert. So they could grow crops and things, and you could have, you know, Warner Brothers.
Yeah.
Yeah.
I saw a TV special on that guy.
Yeah. Yeah.
Yeah, but I forget what his name is. I can't think of it right now. But they had a TV special on him on, I think it was like Modern Marvels or History or something they mentioned him.
There was a movie.
No, it was Modern Marvels, and it was all about water. That's what it was.
What about Florida, Amy?
What about
Have you
Florida?
had severe water problems in Florida?
No, I mean, it gets very dry here, especially if we don't have rain, but not as far as like drinking water. There hasn't been any type of restrictions or anything like that on it. It just our biggest concern is wildfires. So because it's so hot and it's always kind of dry here, we have to have the rain, and usually in the summer it rains every day, but it probably hasn't rained here for about a week now, or at least by my house. So we always get concerned.
I was visiting, my uncle lived in St. Petersburg.
Mm-hmm.
I'm going to guess the 80s, maybe the 90s. And there they had to use, what is it, gray water for watering their lawns?
Oh, yeah, like reclaimed water?
Yeah.
Yeah, see, we're supposed to water only during certain times of the day, just to help conserve, and also because it's so hot, so there's really no point in watering your lawn at like 12 in the afternoon, which I still see people have their sprinklers on. I mean, that's not going to do anything for your grass. All it's going to do is waste water.
Mm-hmm. And some states, like if you're on the coast, I'm in Connecticut, right on the coastline. We don't get anything like the droughts they do, like they're having from California to Texas. We've had droughts to the extent where we've had some water restrictions, but we're right next to water. So if push came to shove, technologically, we could put up desalination plants. I think Florida.
We could do that, because I mean, Florida's not very wide. I mean, you can pretty much drive across the whole state in a short distance, as far as like width-wise. But
you know, even New York City, and I think for instance, New York City could have two choices: conserve your water as much as possible in big New York City, or two, build a massive pipeline to upstate New York and import water down. And that they obviously went with, been going with option B. And they were building, I think, one of the largest tunnels projects in the United States, and I don't know if it's been completed or when it will be completed. But it's going to be a massive pipeline, upstate New York aquifer, to provide water to New York, when they could also, in New York City, conserve water far better than they do. And that's what I said when I'm talking about the other option, managing water, or do China. China has a problem on something like that. All they do is they put in a massive dam. They've got that, is it 600 mile long? It's a huge dam supposed to provide electrical power. I'm not sure it is really working as well as it is supposed to. But that's the Chinese idea. That's the old American idea. Build that big pipeline and get the water from somewhere else, and we don't conserve.
Right.
Moving on to an interesting story that Dale posted on our Facebook. And let me get to it because there's an infographic that I want to share. Okay. Reading from the article, and it talks about the differences between the diseases we donate money to and diseases that actually kill us. And the graphic has developed, it says, a life of its own, and it was developed by Julia Belluz, B-E-L-L-U-Z, and she uses it as a critique celebrity-driven kit. She uses it to critique celebrity-driven campaigns for rare diseases such as the Ice Bucket Challenge.
Mhm.
Yeah, the discrepancy in the graphic is pretty striking, and
Yeah,
it sure is. um,
Well, especially I think among women, heart disease is the #1 killer. The purple one.
yeah. Let's see. HIV may not be. Let's see. Let me continue with the article a little bit, and then we can talk about the graphic. Discrepancy in the graphic is pretty striking and certainly worth thinking about, but it's hardly the last word. For example, HIV might not be a major killer of Americans, but the people donating are probably concerned about the devastation it wreaks globally. Indeed, the article quotes 800,000 Hours founder William McGaskill saying, donating money to the least developing world health charities will reach at least 100 times as many people than if you donate to a developed world health causes. It's also relevant to think not just about the number of deaths, but the number of years lost. Understandable that people who treat a disease that kills children more seriously than one that affects people who are nearing the end of their lives. Timing is an issue. The figures that Belouz used are from the Center for Disease Control, but things have changed. Back when AIDS epidemic was just taking off, some critics said too much funding was being directed to it for the relatively paltry deaths. Actually, I think most of it was homophobia. Certainly good to think about the way you donate, the way your donations can get the most impact. From a society standpoint, that's what this infographic illustrates. And I'll stop there because we can get to the graphic itself. And if you look at the two diseases that are getting the most money, you're looking at breast cancer and prostate cancer. Now, what occurs to me is both of those diseases affect sexuality. The focus, for instance, women, sexuality, is their breast. And I know with some women, and I know some women who have had breast surgery in the past, their concern was they're going to be disfigured. Absolutely no longer true, particularly with breast reconstruction where it is. But that was a major concern. Even, well, I'm talking only about some of the people that I knew, some of the women that I know, a woman I worked with. But that was more of the concern with breast cancer, was the possibility of disfigurement than actual death. With prostate cancer, something somewhat similar, and that is erectile dysfunction. The inability to have an erection because of prostate cancer. And for some people, that being, once again, more of a concern, how it affects their sexuality than actual death. I don't know. What do you guys think? AJ.
I like the colors.
There you go, the colors. Pink for breast cancer because it's a woman's disease.
Well, yeah. I mean, men are still affected, but it's very rare.
That's true. That's true. Okay.
Prostate cancer make an improvement there.
Okay. All right. AJ. Since cancer by far, heart disease by far, and prostate cancer together by far kill more people.
Oh, COPD is the #2.
That's, which color is that?
Blue, the light blue.
The light blue. Right. Oh, that's also a heart condition, a lung condition, isn't it?
It's lung, yeah.
It's lung. And then prostate. So the charities that are getting the most money are not don't involve the diseases that cause the most deaths. Interesting. Does it represent a problem?
I think there might be a problem with where the money is going and making it different.
Okay, Dale. Do you find this graph interesting? Where do you find it interesting? And do you think it represents any kind of a problem?
Well, I think there is a problem. I think, you know, the recent ALS success, it's all about marketing. They've done a very good job at marketing, and you know, they're raising money for their disease of interest. But yeah, that's what this comes down to. There's no sort of intentional steering of things. I think it's just you know, it's like the capitalism of competition between diseases, unfortunately. So yeah, it's too bad it can't be divvied out in a more logical manner. But yeah, I think it's just ALS got really lucky that this went viral, and that's what it is.
You know, I didn't think about it, but remember the pink ribbon campaigns? I don't know if they're still going. Isn't that breast cancer?
Yes.
So there was a very successful campaign that raised a lot of money. So that's what you got to do if you want to raise money. I'm hearing an echo. Is anybody else hearing an echo?
Yes.
Echo?
Yeah.
Is that
I don't know
coming
where it's coming from. I don't know. I
You know
can
what?
hear it when you talk, and I can hear it when AJ talks, but I don't really hear it when Dale talks.
Is it? I'm gonna mute my mic. See if it goes away.
Yeah, me too.
Can you talk, Ed?
Okay.
Yeah, I
I
don't
don't
hear
hear
it.
any echo. Do you?
No, it's on one of theirs.
Okay.
Unless you can hear it when I talk.
No.
That's
Okay.
my microphone.
Minor microphone problem.
I think it's Dale's.
Oh,
Just
no,
because I don't
That's
hear
the
it in the...
Canadian, of course.
It's the Canuck. Just because I don't hear it since you came back.
Yeah, and it's that's true of just about anything. You've got to really have a good marketing campaign.
You do. I don't know. I don't want to like take away anything because I think they've done like a very good campaign and it's wonderful that they've raised so much money, but I don't know. There's just or probably about 90% of the videos that I see for these things have no mention of ALS in them. Like they say Ice Bucket Challenge. Well, the Ice Bucket Challenge started, I think, with like Matt Lauer, and it was for like a completely different charity. And then I think it was Pete Frates or France, I forget what his last name is. He used to be, I think, a baseball player. He has ALS, and so he wanted to do a video because I think he got challenged by somebody, or I don't even know the details on that. And then it started just picking up from there, but 95% of the videos, like the people who post them, they don't even like mention ALS. But I'm guessing that people are researching the hashtag Ice Bucket Challenge, and that's how they find it. But to me, it would make more sense if people got more information out about ALS and were more about like the donating rather than pouring money on their heads.
Yeah.
I don't know.
I think you're correct. I mean, I'm never going to complain that a charity is getting a
Oh,
bunch of money or people are
Definitely
contributing a bunch
not.
of money.
Definitely not. No,
But
especially for a disease such as horrible as ALS.
from a society standpoint, well, cost. That's you know, forget about the human side and just simply looking at cost. Look at heart disease.
Mm-hmm.
Cost for heart disease, the cost for many different kinds of cancers, the cost of all these lung problems. They're costing society far more than some of the other diseases that perhaps are getting more money.
Mm-hmm.
So the decision what to donate to doesn't coincide with society's needs. I said that poorly.
Mm-hmm. And then too, you have these, like when these campaigns go viral, I mean, I know that there's still a lot of people that donate to breast cancer, but whenever causes like this go viral, they seem to fade sometimes really quickly. You know, like they had, like with Robin Williams not too long ago. I mean, people still are talking about it, but those kinds of things need to be addressed, and they need to be addressed constantly rather than just like right after something happens or like right during one of these big massive campaigns.
Yeah.
I think.
Well, I think I tell you what can use a big marketing campaign is science.
Mm-hmm. Yeah.
Scientists really suck at marketing. I don't know that. Boy, NASA, poor old NASA. To jump a bit to another subject, man.
I know people still think that it's dead.
That is, I mean, that agency is such a great thing for the United States in terms of the kind of technology it produces and everything. And Congress continues to cut funding.
Mm-hmm.
And God forbid the Republicans take control of the House, the Senate, like they probably will. I don't know. All right. Let's get on to another very well-written story. And we have the author right here with us, Amy Lynn. I don't want to catch you unprepared. Would you prefer to read the article or let me do it?
You can do it.
Okay. I've edited out parts simply because I don't want to spend too much time talking about these articles. I should also screen share. Let's try the old screen share again. Okay. And the picture I'm looking for is right here. And
Oh yeah, those letters are tiny.
And reading from Amy's article. 2 weeks after the European Space Agency Rosetta spacecraft arrived at Comet 67, I will not even attempt to pronounce it.
I just say 67P.
67P, very good. Scientists have been busy gathering data. And you know, let me say, that's a pretty amazing project in itself. We aimed this particular craft at a specific comet.
Yes.
And we reached our destination, and we're going to get 30 miles away, is it?
Mm-hmm. Kilometers, I think.
30 kilometers away, eventually. And then we're going to land a craft on it? I mean, that is freaking amazing.
And they have to do it fairly quickly because next year it'll be at its closest approach to the sun. So surface changes happen quite rapidly the closer it gets to the sun. So they basically have to be able to land, you know, within a certain amount of time so that they can do the experiments and try to collect all the data that they want to collect.
Will the lander stay on the comet and record information as the comet does move closer to the sun?
Yes.
Okay. Reading on, some little bit more information. Comet 67P is approximately 324 million miles from the sun and it's a 6.5-year orbit around it. The closest approach will be in August 2015, and at that time, both the comet and Rosetta will only be 114 miles. Only be 114 miles. Is that 114 million miles from the sun?
Yes.
Okay. At this distance, the light from the sun will be 8 times as intense as it is now. Rosetta and her panel of instruments are designed to study how the comet changes as it is subjected to increasing solar heat. The spacecraft will observe how the coma evolves and potential surface changes. What a neat package of instruments. It's equipped with its own panel of instruments and will be recording data at the comet's surface. Both Rosetta and Philae will work together on the CONSERT experiment, sending and detect the radio waves in the comet's interior in order to determine its inner structure. That I didn't realize. That's going to be in studying the interior of the comet as well.
And
of course,
pretty cool.
selecting the landing site. Obviously, complex process. A lot of different factors in it, including the technical needs of both the orbiter and the lander during all phases of separation, descent, and landing. Surface operations, considering the needs of the 10 instruments aboard Philae. According to NASA and the European Space Agency, when analyzing a proper landing site, they have to consider large boulders, deep crevasses, or steep slopes. So you really got to know what the landscape of that comet is like. And enough sunlight to recharge the lander's battery beyond its initial 64-hour lifespan without causing overheating. So it's going to be, is it a solar battery powered by... It's interesting. And again, that would be a problem. The closer it gets to the sun, the more it can overheat. And eventually it will get deep fried.
Yes.
The sites were assigned a letter during the initial pre-selection process. I don't know if you can see the little letters there. Basically, in the middle picture, you've got 4. I guess that's A, B, and D. A, B, and D.
A, B, I, and J.
Oh.
So they selected 10 originally. They pre-selected them, and then as the comet, as Rosetta got closer, they've been able to analyze some of those and remove them as options. So now they're down to 5. And then by, I think it's September 14th, so over the next couple weeks, when higher resolution images come in, they'll be able to pick a primary and a backup.
And the last one, that's C. It's on perhaps the other side of the comet.
Yeah, it's on that third picture.
Great.
Next year's going to be really exciting.
That is... I don't understand why the public doesn't see this. I mean, this is an amazing thing.
It's the first time ever that a spacecraft has been able to orbit and land on a comet.
I wonder what the information feedback from the instruments. What is the time delay between there?
Oh, that's a good question.
I wonder, and
I know between like New Horizons, when it gets to Pluto, I know that it's going to be about 4.5 hours. So this one, I would imagine it. What is it to Mars? Like 90 minutes, I think. I'd say somewhere 2 to 3 hours, maybe. But I don't know for sure.
Will this be readings? They will be getting readings. Will it be possible to get any kind of pictures or anything like that?
Yes, they both have cameras, so.
That will be it. Now that's what we should get a live feed on national television audience. Here is a picture, not necessarily live, but here is a picture of a comet. The landscape of a comet. And the landing. I would imagine that'll be a pretty big event, wouldn't it?
I would think so. I mean, the orbiter has, I think, 20 science instruments, and then the lander has 10, so got quite a bit between the two. There's a picture. Can I share a picture in here? Can I just, like, oh, I guess I have a screen share, right? I have a picture somewhere of the different instruments. My computer's slow tonight, though. It's old.
You can post the link in the chat area.
Okay. I'll do that.
Might be a little easier.
What's the difference between an asteroid and a comet?
Okay, so asteroids are mostly like metal, made of metal and rock. And comets typically are like chunks of ice. But they did find under more recent observations from Rosetta that this comet is actually probably going to be like really dark and dusty as opposed to really icy.
So
And
why,
comets have tails, whereas like the asteroid doesn't have a tail. Asteroid's just like a, you know, like a hunk of rock, and then the comet has the coma, which is like an envelope kind of like gaseous material, and it has a tail coming behind it.
and that's from the sun.
Yes, the sun causes the ice and whatnot to vaporize.
It was launched in March of 2004.
Mm-hmm.
Wow.
Wow.
And comets also tend to have like more elongated elliptical type orbits, whereas asteroids have more circular and kind of like huddle up together. They tend to. You don't see like a pack of comets flying together, whereas you could find more than one asteroid. If that makes sense.
I wonder if you can or soon will be able to analyze the minerals that the comet is made up of. You mentioned it would be dusty as opposed to icy.
I would think so. I know there's at least one spectrometer on there, so I'm sure that they can be able to tell what like, elements and everything are in it.
Because that's the some of the long-range projects some people have talked about, mining asteroids.
Mm-hmm. So this is a really tiny picture, but I'm trying to find a bigger picture. But it's a different Rosetta piece, but if you look kind of in the middle of the page, it had the different instruments, but I don't know if you can read it.
So this, okay, so it was launched in 2004.
Uh-huh.
Now, it said it was in hibernation for, it looks like almost 3 years, 957 days.
Yes, it woke up in January.
So that means periodically during that's 10 years. Periodically, they must have woken it up. I
2000, don't know
wow.
if they did it periodically, because I know, like January, they woke it up. I think maybe that was the first time that they had corresponded with Rosetta since it went into hibernation, because they weren't even sure if it was going to wake up.
And which of the pictures? Are you talking about the lander or
Yeah, the
this picture of the
lander.
Lander, okay.
Because I posted a link. It was to a different Rosetta piece, and it has some other instruments mentioned, but there was a picture that was like a diagram. It's in the middle there. So tiny. I gotta find a better picture of that.
So this thing was launched in did they do course corrections? Because it's been
They did some they did some flybys, like 3 flybys I think of the Earth, flew by Mars once, just to gain momentum and then to ensure that it was on the correct trajectory.
So it's slingshotting.
And it even flew by a couple of asteroids on its way out. But since they've woken it up, I'm sure they've had to do, maybe some minor tweaks to the course and whatnot. Okay, I think I found the bigger picture.
So that lander was built 10 years ago. Wow. That's a long-term project. Something that lasted over a decade. And it also showed you, though, how well once they landed on the comet, just how well the technology was even 10 years ago.
Oh, I know.
And you can imagine how much has advanced since then.
Well, just look also at like New Horizons. That's supposed to be like the fastest spacecraft that they've launched. That's going to go further. And they had a panel the other day on NASA TV, and they had some scientists that worked on Voyager 2, and they were also helping with New Horizons, and so it was kind of like the comparison of when they just flew by Neptune and Triton, and when New Horizons flew by Neptune and Triton, because it happened like 25 years to the day after Voyager 2. But I think the antenna on New Horizons is smaller, so we're going to have better pictures, but it's going to take a little bit longer to get to us. It's not going to be quite as readily available as some of the other ones. Okay, so this is a picture. Let's take it away.
There we are. There's some really exciting things happening in our space program.
You see lots of innovation within the space program, but it's just the money isn't there to do these like out of the park sort of things that have been done in the past.
No, I don't watch regular television anymore, so I'm out of the loop as far as the news, most of the major news stations go. But things like landing an instrument on a comet, I mean, that's pretty spectacular. And that is the kind of thing, I mean, it's it's a cooperative program. It's exactly the kind of program we want. European Space Agency, the United States working together. Man, that should be headline news.
Until Bruce Willis lands on a comet, it's not going to make it. So.
Well, I don't know.
And it's been done, right? Like Bruce Willis has been there, so people are kind of sick of it. It's already old news, right?
Yeah.
It's so fascinating. I don't know why more people aren't interested.
Well, we're interested.
Yes, and that's what matters, right? That's all that matters. It's just like the whole Pluto planet debate, Come probably going to go on for another year, but that'll be really exciting when we get those pictures back.
And even with these programs, with missions, etc., and you've now got private financing involved, but the use of that technology to society will probably lag. So the technology that we're building today, its applications for society, we may not see that for a few years.
True.
Science has own landers to comets, perhaps.
Yeah. All right.
Someone's ringing.
Yes.
Okay. AJ, you're a space nut. You're one of them crazy space people, ground-based space explorers, or what was it?
Ground-based space explorers?
GBSE or something?
Yeah, GBSE. Yeah, actually, I'm going up to a NASA event next month in Colorado for the arrival of Maven at Mars.
Woot! Very exciting.
Yeah, get to go to Boulder and also to Lockheed's office down in Littleton, Colorado, I think.
Yeah.
That'll be a lot of fun.
You've been to quite a few events this year, not as much as Amy. Actually, Amy, you've got one of the coolest jobs in the world. You get to go to all these really cool events.
I love it. I want to go to more.
Yeah, I've been to a few. That SpaceX one me and Amy went to was really fun. It's one of the longest.
Yeah, I'm going to SpaceX 4, and then maybe Marshall. We'll see. Everything's all at once.
What's the next one you're going to, Amy?
SpaceX 4, probably. We'll see. There might be another one in between. Don't know yet.
This is really cool because I've been a moon and International Space Station mission, and now Mars.
That's awesome.
Yeah. And then Orbital was the first one, and then SpaceX, and now Lockheed.
Very cool. Yeah. My first one I wasn't really at like a space center, so it was more like a conference, but still really cool.
AJ, when did you first get interested to the extent that you are, when you really got into these space flights and space programs? How did that come about?
Well, I've always been into astronomy since I was a little kid. And just something I've always had a passion for. So I'd say I've just always had it. But there's a new commercialization of space going on right now, and it's a big opportunity for a lot of people.
Yeah.
I just really like getting involved with NASA and helping out with their social media.
How about you, Amy? You don't mind me asking?
Me?
Yes.
Well,
How'd you get this wonderful job of yours? How did you...
Well, I've always been interested in space, and I've always kind of had my head in the clouds, I guess. But
Head in space.
yes, I guess that's a good thing. No, but I went to school actually for microbiology, and when I was going to school, my parents were really pushing medical field on me. So
Awesome.
I was pre-med. I took my MCAT, and then I just never did anything. Went into real estate, and then and then marketing. And I guess it was 2 years ago. I had an opportunity to write for a little astronomy, astrophysics blog, and that just sort of renewed my interest. Or, yeah, I guess renewed is the right word. Because that's my passion, and that's really what I've always wanted to do. So I probably just should have done that from the beginning and been like, okay, I'm going to go my own path, parents. So, but that didn't happen, and that's okay. It's happening now. And then, and then it just progressed from there.
That's great. And there are more opportunities with blogs and things, Spaceflight Insiders. You've got a couple of other.
I do. The universe, it's about astronomy, astrophysics, and then the Earth story. Although I don't do as much for them, just because geology is kind of boring to me, unless it's space-related geology. I'm proud of myself that. Just depends, I guess, on what type of geology we're talking about. But some of it, to me, can be rather dry and boring. But then again, I guess, looking at planets and talking about rockets and stuff can be very dry and boring to some people.
Well, with the commercial, more companies, private companies getting involved, there could be more opportunities. Actually, there could be more jobs created.
Definitely.
In the space industry.
And you learn something new all the time, which is fantastic. When I started, I, had really no idea, and I'm still learning about some of the rockets and differences and terminologies.
Well, that's the thing about science. You've got to keep relearning.
You do.
You got that basic foundation, but everything keeps changing. They keep changing ever more quickly because the technology is getting better. Let me jump ahead to this is a pretty interesting story dealing with photography and entangled photons. And I will screen share a picture here. Now, a pretty freaking looking picture there. And of course, they picked a cat. All things, they had to pick a cat.
Right, like an homage to Schrodinger.
There you go. Think about that. And this is research by the Austrian Academy of Sciences in Vienna. Yeah, that's true. 2 for 2. Physicists have devised a way to take pictures using light that is not interacted with the object being photographed. This form of imaging uses 2 pairs of photons, twins that are entangled in such a way that the quantum state of one is in it's linked to the other. While one photon has the potential to travel through the subject of a photon and then be lost, the other goes to a detector, but nonetheless knows about its twin's life and can be used to build up an image. Normally, you have to collect particles that come from the object to image it, and this is Aaron Zillinger, a physicist at the Austrian Academy of Sciences. Now, for the first time, you don't have to do it. Now, I've got a couple of paragraphs here. This is going to be kind of a joint project of understanding. I'm going to read the project, which is going over my head, and maybe one of you guys can help me understand what the heck they're talking about. One advantage of the technique is that the 2 photons need not be of the same energy. meaning that the light that touches the object can be of a different color than the light that is detected. For example, a quantum imager can probe delicate biological samples by sending low-energy photons through them while building up the image using visible rays, photons, and a conventional camera. Now I know quantum entanglement. So you've got two photons that are entangled. Something that affects one simultaneously affects the other. Now it says photons need not be of the same energy. I would have thought the photons would both have the same energy.
So if they're talking about entangled photons, is what they're saying that the entangled photons don't have to be the same energy in order to see what they're trying to visualize.
Well, they're using that word energy. And then they say this quantum imager can probe, now it says, delicate biological samples by sending low-energy photons. And that would be both photons, would be low-energy photons. They're both low-energy photons, but they say they're of a different color. The light that touches the object can be a different color. Okay, the light that touches the object, that's the photon, that's one of those entangled photons, is interacting with an object that, I guess, has a different color when you looked at it using a mass spectrometer than the light that is detected. Now, light that is detected, that'd be the light coming from the object, wouldn't it?
Yeah, I think so.
How does that fit into photography? Taking a picture of something. Okay, so with photography, you're absorbing the light from an object.
That sounds about right. I mean, I don't know much about photography. But...
Okay, so you've got these two entangled particles. Now I can see that the object, the color of the object being different than the color, the spectrum range of these two photons. Now,
I think what they might be saying, maybe, like usually for just to visualize anything in the room that you're in right now, light has to reflect off whatever object you're looking at, and part of it is absorbed by that object, and whichever wavelengths don't get absorbed come back to your eye, and that represents color.
Mm-hmm.
So I think what they're saying here is, and I'm guessing here, but the photons that they're using to shoot at whatever object that they want to visualize, they're shooting low energy photons at the object they want to visualize, while on the return side they're visualizing that image with unrelated entangled photons that can be at a different wavelength in the visible spectrum.
okay.
Because low energy is, I think, like the red.
Yeah, towards the red part of the spectrum. So maybe that's what it is. So these entangled photons that are creating the image really had nothing to do with it other than the quantum entanglement, whereas the low energy photons that were shot at the object and reflected, maybe. That's kind of an out there guess, but that's a tough one.
Yeah, you're talking about physics, and physics is always complicated. But quantum entanglement, I mean, it really fascinates me because the idea that two particles can be linked, and the distance between them is immaterial. Those two photons could be 2 inches apart or 2 million miles apart. Makes no difference. The effect on one is instantaneously communicated in some way and has that same exact effect on the other. All right. This next paragraph. Zellinger and his college based the technique on an idea first outlined, in which two paths on which a photon can travel. Each contains a crystal that turns the particle into a pair of entangled photons. But only one path contains the object to be imaged. I think we're flunking physics here. I don't know. I thought it was fascinating to me, but I don't know.
It is.
I think that's right. There's two paths where the photon can travel, and each of those paths has a crystal in the way, and it turns the particle into a pair of entangled photons. So that's how they get a pair. Is the particle smashes into the crystal, and the result is you get a pair of entangled photons, and there's two paths. But only one of those paths has the object to be imaged.
Okay. That I can get.
So far I think we're good.
Okay. Two pairs.
Oh yeah, it does say that the cat was picked in honor of a thought experiment proposed by Schrodinger.
I just seen
It says in
too
the
many
latest
cats in my feed.
Oh.
Pictures of cats in my Facebook feed.
Oh yes. Although those cats last night were pretty funny.
So this crystal is what turns the particle into a pair of entangled particles. Okay. And those two particles are going on two different paths.
Yeah.
Okay. Now it says, according to the laws of quantum mechanics, if no one detects which path a photon took, the particle effectively has taken both routes, and a photon pair is created at each path at once.
Right. That's super cool.
So it's alive and dead.
I'm getting involved in observation when they say if no one detects which path the photon took, the particle has taken both routes. That's almost like a psychological question. That little question right there kind of blows my mind.
That's exactly what's happening. Is when that photon splits apart, one is probing the image, and the other one is not. But yet, after the image has been probed by the first photon, they're looking at both photons with a camera or some sort of imaging device, and they're both showing the cat, even though that second particle did not interact with the object in any way. It's still imaging the cat, even though it hasn't passed through anything.
Okay.
And that makes sense, because with an entangled particle, if you change its spin of one particle, it also changes the other at exactly the same time. So they've taken it a step further and used it for imaging, which is really, really interesting.
Okay, so the two photons, these two entangled photons, are taking different paths. One of them is interacting with an object, and the other isn't.
Yep.
But because they're entangled, the one that even the one that is not interacting with the object still is affected in the same way that the photon that is interacting with the image, with the object. Okay. Let's see. According to the laws of quantum mechanics, if I already said that. In the first path, one photon in the pair passes through the object to be imaged, and the other does not. The photon then passes through the photon that passed. All right, let's try this. The photon that passed through the object is then recombined with its other possible self, which traveled down the second path and not through the object, and is thrown away. The remaining photon from the second path is also reunited with itself from the first path and then directed towards the camera, where it is used to build an image. In the first path, one photon in the pair passes through the object to be imaged. The other one doesn't. Okay. The photon that has passed through the object, now it says, is then recombined with its other possible self, which has traveled down the second path and not through the object. Don't quite get that. And is thrown away. The second one being this other possible self being thrown away. So you're now left with one photon. The photon did not interact with the object. That sound right?
Yep.
Okay. Moving on. They imaged a cutout of a cat, excuse me, as well as other shapes etched into silicon. The team probed the cat cutout using a wavelength of light which they knew could not be detected by their camera. That's important. It's proof that it's working. And the cat was picked in honor of Mr. Schrodinger. And there's nothing to say. No. The cat was picked. Excuse me. The cat was picked in honor of a thought experiment proposed by Schrodinger, which a hypothetical cat in a box was both alive and dead as long as no one knows whether or not a poison in the box has been released. In a similar way, in the latest experiment, as long as there is nothing to say which path the photon took, one of the photons in the path is then subsequently created as both gone and not gone. Okay. Help! One of the photons in the pair is subsequently created, has both gone and not gone through the object. What do you say, guys?
Fun.
Okay.
Oh, Schrodinger. There was a video. It was a good explanation of the Schrodinger thought experiment. But I actually think that he came up with that because he really wasn't on board with the whole superposition, like, you know, like wave and a particle at the same time. So he was saying that like it does, showing with his experiment how it doesn't work for large objects such as cats in his experiment. But I think subsequently we've come to find out later that it can work on like the quantum scale. But it was a really cool video. I have to find it.
Well, it's an awesome technique, an amazing, mind-boggling technique they took to create those two images. But all of photography kind of defeats me anyway. Not much into photography. Although I love pictures, I love observing pictures. I just
don't know very much about it.
Yeah. That's also within the with entangled particles. Question has arisen about the speed of the information that's being simultaneously passed between these two objects, and these two particles. So these two particles, I mean, they can be light years away from each other, and yet the information is flowing instantaneously from one particle to the other, or it's having an effect. There's an effect that is happening instantaneously to one, instantaneously happens to the other. Therefore, doesn't that mean there's information that's going faster than the speed of light, contrary to what Einstein says?
So that means we're all part of the same singular mass, right? So if everything started the same in the Big Bang, where it was all one single quantity, maybe it still is.
Could be.
Well, I don't think everything that was created at the time of the Big Bang still exists. Isn't that statement true?
Say that again?
Everything that occurred when we had the Big Bang, everything that happened, all the particles, the plasmas, the energy that was created at the time of excuse me. All the energy that was created boy. Watch the old man die in front of you.
Oh no, you need some water or something. Don't die.
Well, you've got my quantumly entangled Ed Dyer that you can always start communicating with. All right, isn't all of the energy
instantaneously too?
Isn't all of the energy that was created at the time of the Big Bang still in existence?
Aha.
True or not true?
If it hasn't changed.
We're all in the Matrix. Just, do you want the red pill or do you want the blue pill?
Exactly. Uh-oh. I don't know if you can hear that. Hopefully not.
Can't hear it, whatever that is.
Good. Well, I was trying to find that link and the YouTube video started playing and I was hoping you couldn't hear it. But I posted it in the chat. It's the Schrodinger's cat video.
Ed, have you seen The Matrix?
Let me see if I can screen share. Well, we can watch the video. I don't think we can hear it, though. Do you have to hear it to make any sense out of it, Amy?
Yes.
Okay, well then it won't do any good to watch it. AJ,
Yeah.
you've been our YouTube go-to guy.
You can put captions on.
I can try and add it to
Why don't you try working on that, AJ?
Okay.
I'll go on
Ooh,
to...
that guy has lovely hair.
one of my favorite scientists.
Mm-hmm.
So I'll let you work on that. There's one story I do want to get to, dealing with advances in prosthetic technology. Story number 8 in our lineup. And this is it's a hospital in North London. And the revolutionary technology at North London Hospital has transformed the lives of amputees taking part in the trial by allowing artificial limbs to be attached directly to their skeleton, giving them feeling and mobility far beyond excuse me for a second, far beyond anything that has happened before. Okay. Unlike traditional ball and socket joints, where a socket is placed over the soft tissue of the stump, and this is a ITAP, is what they're calling it, involves insertion of a metal implant that forms a direct interface with the bone and sticks out through the skin for the prosthetic to be attached to. If the trial conducted, this is the Royal National something or other hospital in Birmingham, which ended in June, is deemed a success, and it certainly sounds like it has, ITAP can be rolled out across the UK and internationally through specialized clinics. And this is one of the individuals who took part in this trial, Mark O'Leary. And he was one of the first 20 above-the-knee amputees to take part in the trial. And he described the changes it made to his life. Just knowing where my foot is, my ability to know where it is improved dramatically because you can feel it through the bone. A textured road crossing I can feel. You essentially had no sensation with the socket, but with ITAP you can feel everything. It's like they've given me my leg back. I can just click the stump on in the morning and walk as far as I like. Do anything I want within reason. There's no limit. So basically, even with the traditional ones, where there's a flab of skin, I guess, and it goes into that a little bit later, you can have some problems. Blisters can form, and you have to be a little bit careful about attaching it, and then there's friction involved with that prosthetic limb. And this procedure completely eliminates that. The physician who works in the radiological department at St. George's Hospital in South London said that the pre-implant was limited, like other amputees, and how much he could walk. Oh, this is another guy that was in the experiment, that was involved in the experiment. He could walk because of the experiment. Hello, guys. Attempting to read using English words. All right. The physicist, and that's the guy, Mr. O'Leary, who works in the radiological department at St. George Hospital. He said that pre-implant, he was limited, like other amputees, because he couldn't walk because of discomfort caused by the socket rubbing up against the soft tissue. And that was also a further problem with hot weather. And sometimes he had to carry a crutch as a backup. But since 2008, 15 years after losing part of his leg in a motorcycle crash, he has climbed Mount Kilimanjaro. He has completed a 62-mile walk in just under 26 hours. He had blisters on my good foot, and in a way it was easier for me. I had one reliant foot, the prosthetic one, and he said he was walking without limit 4 months after the ITAP was implemented. Wow. Climbed Kilimanjaro. Walked 62 miles in under 26 hours. 62 miles in under 26 hours. That's like a couple of marathons. That's amazing. That's an amazing improvement. let's see. The inspiration for ITAC came after research into how skin forms itself naturally under deer antlers. It found that the antler bone is porous under the skin, and the inner layer of skin grows into the holes. The idea of ITAC is for the skin and the tissue to merge into the metal implant, creating a seal that aims to prevent bacterial infections and enabling a prosthetic to be attached securely and carrying weight in a natural way. May not be useful for everyone, but obviously can make a big difference, particularly with some people who they develop skin conditions, dermatitis, and eczema. With a quick release mechanism, the ITAC is also intended to make the prosthetic much easier to attach and remove than with a ball and socket. Additionally, like a ski binding, the mechanism releases to prevent damage to the bone or implant if you fall. An amazing advance in prosthetic technology. I had a question for you guys. This is a future I can visualize where these advances reach the point where you can go in and let's say you had a problem with your leg. You can go in and have it amputated and a prosthetic put on just like you're going for tooth surgery. Bit of an exaggeration, but that, 20 years in the future, and these advances are happening so quickly, you could have this kind of prosthetic limb put on very quickly, fitted to you very quickly. You could begin using it very quickly. And it could even help you outperform your old limb. I can see athletes, perhaps someday, choosing to have a limb amputated. Let's say you have your arm. It's functioning. It's not functioning the way you like it, the way you want it to. Well, just go in, have the old arm amputated, have a prosthetic arm locked in, put in place, you're good to go. How do you think, Dale?
I think there will be some amazing advances in that sort of thing, but I think eventually we'll have control over biology. We won't need a prosthetic.
Okay.
But I think already short term, I think I saw some TED videos of there's a lady with 2 prosthetic legs, and
she's a model.
Yeah, you can't really call it a disability anymore because she's almost more advanced than many people with those legs. So it's sort of interesting,
Well, she has said that she can change her height. She can decide how tall she was today by putting on a different prosthetic leg.
Yeah. So it's getting so advanced. It's kind of there's advantages for sure, and that's a great thing, right? If you don't have your legs, and there's some advantages to that. The more that can happen, that's a positive thing. But I think eventually, science will get to the point where you'll take a pill and you'll be able to digest the entire works of William Shakespeare.
What color pill would that be?
I hope it's blue. 'Cause I love the blue pill.
Right.
A pill. So all the knowledge in that pill gets filtered up into your brain.
Which would work if we were all holograms, because that's what they do in the Matrix.
Good point, Amy.
Want to learn a new language? Oh, hold on. Let me download that real quick.
Yeah, just swallow the pill.
Yep. Oh, look. Je parle français maintenant.
Exactly.
Would you agree to have an implant, a connection in your brain, something, some sort of an interface between your brain and, let's say, the internet, or so that you can interact with the internet by just thinking?
I would be like leery of that. What if you get hacked?
Ah, there you go. Okay.
I don't want someone to hack my brain. I'm pretty sure people don't want to be in there anyways, but it's entirely possible. Look at how people hack the internet. I mean, I'm just assuming that they could be able to do that, but seems like that would be a step closer to allowing someone to control your mind. Not that doesn't
Yeah, I think
inadvertently happen.
Yes, I agree. I think that's where my stopping point would be, the brain.
Yeah,
I can't be
I
messing
think
around
so
with my brain. I might need a new leg, a new arm, or whatever, but you're not going to be messing around with
No.
Oh,
Did anyone hear about that article where scientists found a way to email brainwaves over the internet? I'll throw it in the
I
chat.
didn't read it, but I think I saw that.
Yeah.
emailing.
What is
Brain. Oh, you know how secure email is.
Oh. I just be able to have a thought like, Ed, are we about to have the podcast? And you'll just get it because I have the thought of it.
Okay, guys. We got to do something about the way they create words in science. Are you looking at that article by any chance? Look on it. You got a brainwave sensing technology which utilizes, what the heck? Electrocephalography powered headset?
Cephalography.
I don't know.
That's an easy one.
Interesting. It says they were able to convert the words hola and
Hola. Hello.
hola.
CO. It's not CO.
Yeah.
One person's brain waves into binary and then transmitted that. Oh yeah, I read about that to another subject.
This could actually, I guess, going back to the other story about diseases, couldn't it help people that had something like ALS and maybe they lost a new way to communicate besides a cheek attachment like Stephen Hawking has?
Okay.
I guess it could be
Thought
good for things
wave,
like that.
mind meld, a thought. Mind meld thought thing.
Maybe if you have to have that to be able to communicate, that would be something. But as far as wanting to do it, I don't know.
Yeah. Okay. My brain is dead. My brain is beginning to die.
Pretty soon you're going to have to email us your thoughts, huh?
All this reading. You know what's happening? I'm reading all these words, and they're slowly mingling into my brain, and they're getting confused. And I'm reading one story, and I'm thinking about another story.
Oh, yes. I know the feeling. How every day is. And then you have days where you want to be away from the computer and you think that you get to be, and then all of a sudden you can't.
Well, one of the things to touch on is the fact that this keeps your mind active. Keep your body active, and you keep your mind active. And man, with all these stories I can create my own site, scienceisland.org. All these things are keeping my brain stimulated.
Exactly. Takes a lot of work to put those stories on your site. That is one thing I'm just not good at. I can write stuff and I can pick a couple pictures, but I always pick crap pictures as far as like not choosing the exciting ones. So luckily my editor goes back and fixes them for me because he always picks the best ones.
How about, I mean,
I don't think I could make it as a graphic designer.
Have you posted some parrot pictures, or was that copied from someone else? I saw some parrot pictures on my Facebook feed. I think it was.
Oh, it could. It's probably me. I mean, I do take a lot of pictures of my parrots. They were probably like, okay, stop.
How's that? What if you could read your parrot's mind? What if you could communicate telepathically with your parrot?
That would be cool. Although one of them, I don't think I'd want to know what she's thinking.
That was going to be my next question. We want to hear what the parrots are actually thinking.
Oh my gosh, the little one is just so funny sometimes. Because like you'll give her something to eat, and she'll shake her head. Like she'll be like, nope, nope, not gonna do it. And then other days she'll be like, okay, I'll take it. Really don't know. I'd really like to know what they were thinking.
When you were talking about them before, you were in another hangout. One of the things that really I found interesting is that you say you actually raise it from an egg. You hatch the egg. I didn't even know that.
Well, I didn't hatch the egg, but I've had it from without feathers. So, yeah. And,
were you there when it hatched?
And not when mine hatched, but I've been there for babies that have hatched. I used to work at a bird store for 5 years, and so I was like the main hand feeder. And it's a lot of work. Because, like we have a trachea, you know, like we have the 2 tubes, whereas birds, they only have 1. And so, like their lungs, it's kind of like an opening. So it's slightly different. I mean, they do have like the crop, which is where their food goes and it gets digested, but they can very easily, when you're trying to hand feed them, I guess, use a syringe. So it may be how the syringe is designed, but they can very easily aspirate. So you can fill up their lungs with the hand feeding formula, so you have to like really know what you're doing. And with the tiny ones, it's even harder because the syringe is almost as big as their mouth, like the opening, and they do not take a whole lot. So it's like once you get the hang of it, it's pretty cool. And sometimes, like when you're first learning, especially with macaws, because they eat a lot. Probably, I'd say that as they get older, they can get up to like 120 cc's at one time, which is a pretty substantial volume, and you can just see like the little crop expand, and you're like, oh my gosh, how can they fit that all in there? That's like probably the thing that I miss the most, because I have the birds, and working at the bird store and interacting, it was basically like a zoo, like working at a zoo. So I would be like their little caretaker, and each bird has their own distinct personality. They're just like people. Like their personalities and everything are that diverse. Like I don't think I've met one that has like the same, that's exactly the same.
What about the bonding? If you're there and they're very young and you're feeding them, do they bond with you, and is that a problem when you have
No, it's not really. Like they do bond with you, and I do think that they remember you. Because I've had babies that have come back after they've been sold, whenever I worked there, and I think that they do remember you, but whenever I worked at the bird store, we would always encourage the owners to come in and to socialize with them, because Birds are monogamous creatures, so whenever you adopt a bird, you essentially take the place of their mate, which some birds bond more strongly than others. Like mine, she I think it's because she was mistreated, but she'll tolerate other people, but she doesn't really like them, and she gets really leery. Like you have to let her warm up to you. Whereas some of them will just go to anybody and everybody. They're like, okay, hi, you're my new best friend. And then sometimes birds only like one person, so I guess it depends. A lot of the times on like how much you socialize them when they're little. Like if you take them out places and if you have a lot of people over and you make sure that multiple people handle them, then chances are they're gonna. And I think different species too. Certain species are more easily one-person birds, and certain species are more everybody birds. Like cockatoos. Cockatoos are like the clowns of the bird world. So basically, whatever kind of attention they can get, they eat it up. Those are like the white ones, like the Beretta bird.
And parrots, at least some of them, they can be fairly long-lived.
Mm-hmm. Like macaws can 80,
Mm-hmm.
80 years, yeah. I mean, my little lovebird was 20 whenever he passed away, and I just found my African Gray's hatch date the other day, and she'll be 19 next month.
You found her hatched egg, and
Her
that's how
hatch
you
date?
could date her?
No, the date. Like, you get a certificate. Yeah.
Hatch date. I'm sorry.
Like, they'll give you a certificate.
Some people keep little things, little like gold, bronze things to their baby's first shoe and stuff. I don't know.
That's true. That's true. No, but usually the breeders that you get them from, or like a store, will give you a hatch certificate, like a birth certificate, and it'll have the date and everything on there. So I have all that, and I have their sexing certificates because I had them DNA sexed, so I know if they were male or female.
You have to have DNA to tell the difference?
For most of them, yeah.
Just stick your finger up your butt.
No. Although I think
Doesn't
some people try to do that and like say that you can do it that way, but I think the only I think I think the only for sure way for parents, because they try to feel like like how spread apart their bones are to see if they can accommodate eggs and stuff. But I think DNA sexing is the only for sure way.
I like to have some empathy. Like if someone was sexing me to find out my sex, I wouldn't want that same process done to me. So.
I mean, like a drop of blood is very like non-invasive.
Yeah.
They have a little vein in their toenails like dogs and cats. So whenever you're trimming them, sometimes they bleed, and so that's usually when you would try to DNA sex them, as you would collect the blood then. And it's so easy, and they don't even get upset by it.
That sounds a lot more pleasant.
Yeah.
Oh, yeah!
Can you tell? Like, you could wait for them to lay an egg, so, like, because not all of them do. I mean, I have 3 girls, and hopefully, knock on wood, none of them lay eggs. Don't want to deal with that.
Can you, they can read, they can communicate, they can read communications from you. Is what I'm getting at. Can you tell what they're, from either the way they squawk or their behaving?
Yes, I can. I know what their squawks mean. And they are all different.
They have different squawks. I didn't know that.
Yes, they have like a happy little one, and then they have one that's like something's really wrong, and then sometimes what they'll do is they'll hang on to the cage with their feet and they'll flap. It's kind of, I guess, their form of exercise, and they make a screech when they do that. And if you're not used to it, sometimes you think something's wrong, but they're just exercising.
Hey, I got to run, guys, but thanks again, and I'll probably see you all next week.
Yeah, great.
Awesome.
Later.
I will. It's almost 11 o'clock. This Week in Science is starting shortly, so I will
Oh
end
yeah.
the broadcast. Great talking to you. I see you. Bye.